Hi everyone, I'm Michelle of Michelle Batra Skin Science, and today I'd like to talk about acids in skincare. So I want to do a little bit of an overview of those, give a little bit of the science behind the acids. I'd like to have a good blending of the two. A lot of times when you look up acids in skincare, they'll give a very generic basic reasoning like, oh, glycolic acid does this, it stimulates collagen production, it helps with lightening. But for me, someone who likes to understand the science behind things, it doesn't really go into the depths of why. It's just like, oh, alpha hydroxy acid. Well, what is that? What is an alpha hydroxy acid? So we're going to get sciencey for just about a minute, maybe two. Stick with me through it, and then it'll hopefully help you understand a little bit more about the acids themselves and why we want to pick particular ones to use in our skincare. I'm going to plot a little diagram of the most basic alpha hydroxy acid. Here we go. This is glycolic acid. Just a few parts to it. We have two carbons. This is a carboxylic group. It's a carboxylic acid. So a carbon double bonded to an oxygen with a hydroxyl group, an OH. Next to it is another carbon, and coming off of that carbon is a hydroxyl group, an OH. This is what we call our water soluble. The hydrogen is able to hydrogen bond with other atoms. So like the oxygen, it's going to form this bond between the oxygens of the carboxylic acid portion. And the reason it's called the alpha hydroxy is that it's one carbon away. So the hydroxyl group is one carbon away from the acid portion. So if that was too much, then just kind of go with it. Just look at the diagram. It's like basically it's one space away. And how that pertains is that functional group is a short distance from the acid and allows to have that stronger bonding. We'll go into a beta hydroxy now, and this one is salicylic acid, coming up right there. And the reason it's called a beta hydroxy acid is that here we go, here's that functional group again, the carboxylic acid portion, and it's here would be the alpha, so one carbon away, but we go two carbons away, and there's the hydroxyl group, which is a greater distance and allows for weaker hydrogen bonding between those two functional groups. In addition, salicylic acid has this phenol group, and we'll get to that in just a minute. I want to keep those two distinct and separate. So now we get into the easier portion of just listing through the acids in skincare. You've possibly heard of glycolic acid. It's been used pretty prevalently in skincare. The reason dermatologists like it and other skincare companies is that it has been shown to can reach down to the epidermal-dermal junction, which is where our melanocytes are. It helps dissolve that intercellular glue. And so what that does is it expedites the exfoliation process, increasing cellular turnover, which is what we want as we age. Our cellular cycle of exfoliation, cellular turnover, slows down as we age. A healthy cycle is around 4 weeks, 28 days. As we get older, if our immune system is compromised, that extends anywhere from 6 to 8 weeks. And so that's why a lot of women as they age go in for facials, or they increase their acid use to help that cellular turnover process, stimulate collagen production, and to help plump the skin as well. And if you have pigmentation issues, it can speed up that process of moving out pigmented cells faster. So yeah, glycolic acid is the smallest of the alpha hydroxy acids with two carbons. That's why it's able to penetrate faster and deeper. It works its way in there. So something smaller can get down faster, like a little mouse. It can just reach in little crevices. For someone like me, I would not use glycolic acid. It's a little bit intense for someone of possibly Indian heritage, people with more melanin in their skin. And some people might disagree with me on that. Having worked on a lot of ethnic skin and people with more melanin in there, it can be a little overstimulating and cause PIH, like post-inflammatory hyperpigmentation, and actually be a little too stimulating, causing the adverse effect. We don't want to create more of an immune response in the skin. Next up, we have lactic acid. It has 3 carbons, so it's a little bit larger. It still has exfoliation. It can help with brightening. It actually stimulates hydration in the skin. We have citric acid. That one is also 4 carbons now, and it has the carboxylic group. It is a tricarboxylic acid, which means that it has 3 of those functional groups that we saw. We have malic acid, and that's usually apple-derived, and that's a dicarboxylic acid. Then we also go into mandelic acid. Now, mandelic acid is a really fun one because while it's called an alpha hydroxy acid, it has a phenol group. Let's pull up our little diagram once again. It has a phenol group like this, which gives it oil-loving properties, or, you know, when people say, oh, salicylic acid is oil-loving, well, that large phenol group, it is not water-soluble, so that's when you say, oh, it's attracted to the pore lining. It helps to dissolve the pore lining of, it has both AAH-like properties and BHA-like properties. So mandelic acid is absolutely one of my favorite acids. I love formulating with it. I think it's fantastic for acne. I think it's good for anti-aging. And because it has those AHA properties, but it's also a larger molecule, it works slower in the skin, creating less inflammation and inciting the skin less than the smaller molecules like glycolic, lactic, citric. Okay, and now we'll move into the beta hydroxy acids, and the only one that's really used in skincare is salicylic acid. It's probably one of the #1 go-tos for acne treatments because it has that ability to sort of dissolve the pore lining. It has some antiseptic properties. It is not bacterial, and it's not bactericidal. It doesn't kill the bacteria, but it does have the antiseptic qualities and has exfoliation. So if you've ever received a salicylic acid peel and that heat that you feel, like calling it a beta lift, where you put it on the skin and your esthetician puts a really cold towel on and the skin flares up to like a 9 or a 10 on a scale of 1 to 10, that is because of how it sits on the skin, that large molecule, and it's heating up as it exfoliates and sort of melts the top layer. We'll do a fun experiment in the sunscreens video where I show you under a woods lamp or a black light just how it peels away the skin for the future. Okay, so gonna wrap this up. Don't want to keep rambling on forever. Hopefully you're able to retain some of this information on the acids. Another one that I'd like to include in there is TCA, trichloroacetic acid. It's sort of an analog of acetic acid, but instead of hydrogens on that carbon, it has 3 chlorines. And typically that's used more in a peel. I don't see TCA a lot in over-the-counter skincare. TCA peels can get down to a pH of under 1, like peels that I've made with TCA, one of the pHs once, and that was like a 0.9, and that's okay if that is administered under a doctor care or someone who is very skilled with peels and knows what they're doing and knows how to bring down the pH of the skin. So let's bring these acids into context now. I've sort of said them what they are, their molecule sizes from smallest to largest, how the smaller ones penetrate deeper. Larger acids sit higher in the skin, but they still have very beneficial effects. pH, hands down, is probably the rate limiting factor. So I could have a glycolic acid at pH 7, and it's really going to do nothing on my skin. As you go down each level in pH, it becomes 10 times stronger. So pH of 5 is 10 times more acidic than a pH of 6. A pH of 4 is going to be 100 times more acidic than the 2 levels up from that. Buffered acids. So a buffered acid is sort of controlling and containing the pH. It's regulating it at a certain level. So if I buffer an acid, I'm holding it at a pH, which means that I only have a certain percentage of free acid to work with. I think I'd like to expand on this in another video. I don't want to go on forever. You can just keep getting into depth about acids, and really I'd like to keep it at a general overview. I fear I may have gone a little off on a tangent anyway, because there's so much to share on these acids. So I think let's just leave it right there for now, and I'd like to expand a little bit more later on. Not every acid is right for every single skin type, like I said. So that is why really working with a professional or someone who's been in the skincare business for a while can help you navigate that terrain. I like to gear people towards acids after knowing their skin conditions that can really help them. So even working with dermatologists, when they kind of as a blanket statement, I love glycolic acid and they want everybody to use it, I don't necessarily believe that. I think derms know skin so well, but your skincare professional knows acids and how to use those acids in the skin, and also the skin types that can maybe respond to them differently. So I think that's a topic for another time. We'll do acids part 2. Thank you for listening. I really appreciate the viewership, and if there's any way to improve on anything, please make suggestions. If you like the topics that we cover, go ahead and subscribe to my channel. And that's it.